want to remove the hidden hunger. We want to actually feed our population. So in this way, these two objectives are there behind this climate resilient grains. The first one is the climate change we have to keep in mind. The second is malnutrition.
Subscribe and press the bell icon so you never miss an update from PrepLadder.
Now, the next thing is about the climate resilient grains. We have seen the things about the amok. The climate resilient grains, if we talk about, so Prime Minister released 35 crop varieties. Now, what are these climate resilient grains? Because temperature is changing, climate change is now the new normal thing. So, at one hand, temperature is increasing, drought possibilities are there, means drought possibilities are increasing. So, we need a crop which is not only resilient to this temperature or drought, means this should be drought prone. Along with that, the nutrition value should be higher one, because we want to remove the hidden hunger. We want to actually feed our population. So in this way, these two objectives are there behind this climate resilient grains. The first one is the climate change we have to keep in mind. The second is malnutrition. So with this thing, we have come up with the 35 crop varieties. And now this Indian Council of Agricultural Research, that is ICAR. So it is actually addressing these two challenges, and we are coming up with this such climate resilient crops. Now, if we talk about this climate resilient crops, so we have seen they should be resilient to the climate change. They should be prone to this drought or the temperature change. So we came up with this National Innovation in Climate Resilient Agriculture, that is NICRA, in 2011. So it shows how much we are focused on this type of the initiatives or the crops. Now, the next news is related to the black carbon in the Himalayas. So there was a report released by World Bank. It says glacier of the Himalayas, climate change and black carbon and regional resilience. So we have seen this IPCC's sixth assessment report was there, and the second report of this sixth assessment report talked about the regions which are highly vulnerable to the climate change. And in this region, the polar region was also there, and we do have the Himalayas, which is kind of vulnerable to the climate change. And this is the second report that is from the World Bank, which talks about the glacier and the impact of climate change on this glacier of the Himalaya. Okay, now these are melting faster because of climate change. This is the report's prediction. Now, if we talk about black carbon, so it is actually getting deposited over the Himalayan ice. If, for example, this is the Himalaya, and here you will see the ice cover is there. Now, because of many regions, the black carbon is getting deposited over here. So earlier, if we talk about albedo, so if you have heard about this albedo, so ice albedo was very high, means if the sun rays are falling over the ice, it will reflect most of the part of the sunlight, and this is what we say, that is the albedo. So albedo is the reflecting capability. If we talk about ice, the albedo of this ice is very high in general, but because of this black carbon is now getting deposited over this ice cover. Now, because of this black soot or the black particles, the albedo of ice is now decreasing, because black is known for its absorption capacity. So this sunlight will be now absorbed because of this black carbon components. So what will be there? Definitely, earlier the reflection was there, now the absorption is there. This is definitely going to increase the temperature. And because of this temperature, the melting of ice glacier is occurring. Okay, so melting process is becoming faster. So this is the reason why this melting is going faster, because of this black carbon. Now, if we talk about this black carbon, so black carbon are the particulate matter particle, that is 2.5, and how it is formed because of the incomplete combustion of fossil fuels. So all the fossil fuels have the carbon components in them. If the complete combustion is there, so what will happen? You will get the fuel, you will get the energy. Along with that, CO2 emission would be there. Okay, the complete CO2 emission would be there. Now, because of this incomplete combustion, this complete CO2 formation won't be there. What will happen? Now you will see some of the carbon monoxide would be there, that is very toxic. Volatile organic compound, that is VOCs, would be there. Organic carbon would be there, black carbon would be there. So in this way, because of this incomplete combustion, you are going to have the black carbon in output, brown carbon in output, carbon monoxide in output, that otherwise could have been the CO2 if the complete combustion would have been there. Okay. Now, because of this carbon, we have seen the ill effects of this carbon on the glaciers. Now, this complex mixture of the particulate matter would also be there, that is known as soot. So, soot is nothing but the complex mixture of various particles or particulate matter. Okay. So, this is going to impact definitely the cryosphere, that is snow and ice, agriculture, as well as human health. So, black carbon is very much harmful for all these: agriculture, for human health, for cryosphere. Although it is a short-lived climate pollutant, but still its impact are very much visible when it comes to the melting of glaciers, when it comes to the agriculture, when it comes to the human health. Okay, so this is about black carbon.